Hopefully you're all here for this session. If not, there's still enough time to leave. I'm Anna, I'm a developer advocate at AWS, and I'm very honored to be joined by David here. He's an AWS community hero. Thank you, David.
Thank you for the invite. My name is David Victoria. I'm from Mexico. Sorry for my bad English. So today we're going to talk what are these agentic workflow means and how we can take advantage on the local LLMs. So first, let's start about the pain point, the cost of downtime. Aberdeen research told us that in the average cost of unplanned downtime of industrial operations are more than 2,060 grand per hour. So there are a lot of industries affected by these problems. So Anna will take the stage on that.
Yeah, we'll cover some of them, but there are many others. So mining, you're underground usually without any signal. There's manufacturing where you're in remote plants with legacy infrastructure. Oil and gas, usually on offshore platforms, many miles into the sea. Energy, government with data sovereignty requirements, and retail. Just a few of many industries that can be affected by this problem. If we want to run AI agents, you require cloud. So what's the cloud dependency problem that we've been talking about? We're at a factory and we want to analyze sensor data. And if we have internet connection, everything's okay. We talk to agents through Bedrock and we're good to go. But once that connection goes down, then we have a problem. What do we do? So what do agents require to work offline? So first of all, agents are powered by large language models, so they need to think, they need to reason locally. To that, we're going to be running those agents locally. Agents are powered by LLMs, but they need the ability to take actions, and agents do that through tools. So they also need to be able to use those tools locally, not through internet. They need to keep context between different sessions, so they have memory. And then finally, once we have connectivity again, to sync that information to and from the cloud. All of those things are required for agents to work offline. And the solution that David and I found and we're bringing to you today is using Strands Agents SDK and Ollama together to have the power of agents in the edge.
Let's ask Anna to the audience, who have worked with Strands Agents or an agentic orchestration tool?
Show of hands.
Great, fantastic. Who has used Ollama to run locally? Perfect, fantastic.
Okay. So we're all on the same page.
Totally agree.
So the hybrid architecture that we built and that we're proposing here today is using Strands Agent to do the reasoning, using tools, having memory. And when we're offline, we're using models through Ollama and the custom local tools that we created for Strands. And when we're online, we're back into the cloud with Bedrock.
So talking a little bit about Ollama. Ollama is an open source tool that helps us to run lightweight LLMs on our own computers. In fact, I can run in my old MacBook small models like 8 billion parameters Qwen. But we have a catalog of LLMs that we can use with Ollama. We have models from from Google, for instance, Gemma 3, Mistral AI, powerful models from Meta, Llama, basically, DeepSeek, Phi, Qwen, GPT-OSS, and many more other models that we can run in local facilities. So,
Ollama will be giving us the power of the model, but agents require not only models. There's this whole thing that we call the agentic loop, where it performs a bunch of steps until it's happy with the response, and it sends it back to the user. So how does it work? First part is the reasoning part, where we receive the user input, we process that input with a large language model, and then the model decides if it needs to call additional tools or if it's ready to send a response or not. Then we have the actions, which are the tools that the model can call.
With these actions, we are going to send and receive inputs that can accomplish the task that the agent is trying to finish. And if the agent determines that it's ready to respond to user, the agent responds the final output to the user.
So it's why we call it a loop. It keeps iterating between reasoning with the model and actions with the tools until it's happy with the response. The tools help add additional context to the model, and then it gives the response back to the user.
And that's why I say that the agents are loops with superpowers. So write these loops, super powerful loops, it's hard. So that's why we want to introduce yourself Strands Agents. Strands Agents is an open source Python and
since yesterday, also TypeScript.
Yeah, SDK for building agents using just few lines of code. Basically, Strands Agents is a solution thinked for builders. So people that actually write code. We're not reinventing the wheel. We are only putting the same capabilities as a builder or developer needs for agentic purposes.
Yeah, and not only it's easy to use Strands, we're going to show you the code right now, but it also is extensible. So we can add tools, MCP, memory management, a lot of different things to make our agents more powerful.
And we're not only using Amazon Bedrock LLMs. In fact, we can use Ollama for sure. We can use first-party APIs like Anthropic API, OpenAI API, and other vendors like Grok, etc. So it's a very extensible tool and agnostic, let's say, for a single vendor.
Yeah, so we create the model, we give it the tools, all the information that it needs, the capabilities that it has, and we can simply switch to different models if we want to.
So let's start reviewing a single agent, the most basic agent. First, we have to import the library. We import Strands. And then we can instance an agent with the default features. What is the default features? Basically, Amazon Bedrock with Cloud Sonnet 4.0 in the Oregon region. That's all. So after that, we can start working with an agent, sending a prompt, receiving an answer, accomplish this powerful agentic loop.
So this is the simplest agent that we can create using Strands. If we don't define a model, we're using the default one.
But how about if we talk about an agent that works locally? So we need to import only the Ollama model library. In this case, I'm importing some tools that are that I create before for my workload specifically. For instance, I create a tool for read sensors, trigger an alert, etc. That custom tools are created, and we're going to talk about a little bit later about how the tools works. But let's continue with the code. Great, so now I am creating an agent, but setting the model is Ollama model, where we have running now Ollama and our host. We define the local host, the port, and the model ID. In this case, we are using DeepSeek in the 8 billion parameters model.
So in the previous example, we're not specifying the model. Now we're specifying this model through Ollama.
And for sure, we need to include the tools that the agent will be able to use to accomplish the mission. The system prompt, basically what the model needs to accomplish. What is the main task that the the agent will work with?
Yeah, I like to say that it's the model's personality.
One important thing that this system prompt have is that we are indicating that this model this agent is working fully offline. So the model will not try to reach internet or to reach external source or features. At the end, we only start working with the agent, sending a prompt, in this case, checking out sensors, and alerting if anything is wrong. How? Using the tools that we have previously defined.
So here with less than 20 lines of code, we have a local model using Ollama and custom local tools that our model can use.
Perfect. So our agents need to take action. So how agents take action outside the world, that's the meaning of the tools. So how a tool works. Basically, the agent uses a tool to make an action externally. I always say that the tools are like the small handies of the agents because have this powerful to extend the capabilities outside the scope of the single agent. So what kind of actions we can take? For instance, in this case, in these specific workloads, read sensors, analyze images, query some databases, create work orders, send alerts, or anything that we can code. How it works.
Here we're going to talk about things and then show you the code. So here's how we create a Python function that we can turn into a tool. Same as before, we're importing the agents and now the tool from Strands. Creating the function to read sensors. And then we have some important info here in the documentation, no?
Yeah, that's right. So this function, Python function, read a sensor, we receive the sensor ID, and we have a local endpoint to pull some data. So this gateway URL, we are using request as a library to get the data from the URL, and that's all. We receive the data from that Modbus TCP, raise for a status, wait for that, have the answer, create a JSON to return or a dictionary to return in the function. But the most important thing here is not the function itself. It's the decorator, the tool decorator. With a single decorator, we are creating this specific function. We are converting this function into a tool that an agent can use. One important thing, Anna, docstring. It's a way that we define the agent, what is the purpose of this function. In this case, the docstring says that you can use this for read real-time data for industrial sensor, and the arguments that you have to send is the sensor ID, and that's all. The agent with this docstring will identify how to create the invocation process, the execution process of this tool.
So the docs are super important, so the agent knows not only what the tool does, but what information it needs to call that tool. And apart from custom tools, like the ones that we just showed you, Strands has a set of tools that are ready to use for the operations, for the actions that we most frequently use. So it has an HTTP request one that we can use to query APIs, talk to sensors, has system ones that we can also use to run local diagnostics, workflows. We can even give in to a human in the loop when we need more critical approvals.
And this is super important because, agents can work autonomously, but the best practice indicates us to use human in the loop to validate that capabilities.
And file operations. So here, my personal recommendation to you is to check the Strands documentations to see the ones that you have available, because I did create a custom tool to save files, and then I figured out one already existed.
And there are many more. I mean, there is only a subset of tools that we find valuable for these workloads, but there are many more community-built tools. And one more important thing about community tools, remember that Strands Agents, it's an open source solution. So you can make a fork, create a tool, open a PR, and the Strands Agents maintenance team can validate that tool and maybe include into the next release. Perfect. So let's talk how we can interact with other caveman systems.
So we have our agents running in the edge, and even though we're used to now having Gen AIs and chatbots and models wherever we are, there are still systems that require
old systems that
yes,
require
more
API calls.
Primitive data.
So that's why we have the structured output. As Anna mentioned, we have some ERP, CRMs, MIS, etc., that talk with other systems using, let's say, APIs. Hopefully, maybe a lot of these systems use REST APIs, but other systems still use SOAP envelopes to communicate with. So with the structured outputs, how it works? Basically, the agent can receive a Pythonic model. Pythonic model is only a thing to define a data structure. For instance, we have a set of data that we need to send to the API, so we can define the specific JSON format, let's say, and then we can send the Pythonic model to the agent and receive the specific JSON as our answer without any other data. You know, models are very verbose.
Yes. So we don't want to get a bunch of text and send that to an external system that's expecting an API call with specific data. That's why we are using structured output. And Strands has a really nice way of doing that. So we're using Pydantic here, as David mentioned, and we're creating this model for a work order. So here we're specifying the fields and their types, and we even have a description so the model can have additional information on what those fields are. So we have a part ID, the priority, description, and estimated hours. And that's our structured output. And now when we are interacting with the agent, we send the agent that exact information so we can answer us with the data type that other systems are expecting.
In this example, we are talking with the agent that the compressor have an abnormal vibration. That agent maybe have some tools to analyze that information, and with the structured output, we're creating a JSON or a dictionary with that specific fields in the exact order using the same values that we are expecting to. So after that, we can validate that results, get into that variables directly as part of the code, and at last, we can send this information to an external system without any intervention. Automatically, the agent is capable to create the JSON and send into the API.
So instead of sending a very large text saying, probably excellent question, this is what you're looking for, we're sending the specific data our external systems need.
Fantastic.
Okay. So up until now, we talked about tools, which are how agents take actions. We talked about some community tools.
That's right.
And we talked about how to structure our output so our agent can communicate with external systems.
What else?
What else do we need? So our agents, we don't want them to forget things that happened, right? So if a specific machine required maintenance or was showing an abnormal temperature or something, we want the agent to remember that.
So we have session management. Out-of-the-box session management with persistent memory with Strands Agents. So in the case without sessions, maybe we are interacting with the agent and asking about check on pressure, or the agent found some important data, but maybe the app crashes, the legacy hardware that we are using power off,
There's a power outage, yes.
So if the app there starts and you ask again, the agent will say, what are you talking about, man? I don't know what are you talking about. So like me yesterday at the Omnia.
We don't want that to happen. So with sessions, it's a whole different story. The user asks the agent to check on the compressor, and then if the app restarts, the agent can keep the conversation going.
Great. So how it works? Basically, we only need to import the library. So we import file session manager. It's important to notice that Strands Agents have other ways to manage the sessions, like DynamoDB, S3, etc. But in this case, we don't have connection. We are not going to use that tools. So we are using the file session manager. We only have to define the session ID that can be a unique ID per user, per unit, per machine, etc. And we are going to store the data. In this case, we are storing the data in JSON format locally in the same computer that the agent is running. And the agent will receive the session manager instance, and that's all. The agent will be able to communicate and remember things across the context.
Yeah, and here we're using the local file system, but we could be using SQL or Redis, or if we're connected to the cloud, other solutions.
At last, Model Context Protocol. This is a well-known protocol created by Anthropic last year. We are now in the version 2. And Model Context Protocol is basically a tool that other vendors can expose to you. You can install or instance in your Strands agent, and automatically all the tools and data sources that that MCP describes are available for you. What do we have in the code? Let's check.
So we have our imports, as usual. And one thing that I appreciate about Strands is that we can import those tools from the library and use them, same as we did for the session management or for the custom tools. We don't have to be creating things ourselves.
We import our custom tools, and in this case, I am importing or calling an MCP server from MongoDB. Notice, sorry, that at the end of the arguments, we have a local host URI. So we are invoking a Mongo collection locally.
So if you're using MCP servers on your coding assistant or on cloud desktop, you're used to that type of information. But if not, we just need to say how the model is going to communicate with that information. Here's locally, so we're using UV, and then the arguments for MongoDB.
After that, we need to have to import the full list of Mongo MCP, and then pass as a tool into the agent. So MCP is no more than like tools exposed by third-party vendors that you can import as a custom tool.
Yes, but here instead of David and I creating custom Python code that would connect to our local MongoDB database and get that information, we're using the MCP server that already exists for that. And we can keep talking to the agent as we've been doing so far.
So in this case, with this Mongo MCP server, we're able to communicate to the database, show collections, insert attributes, insert data, modify data. We can delete data too. So it's important to implement human-in-the-loop process to validate if the action that the agent is going to take is the best path to accomplish the task.
Yeah, and here we're saving log information to MongoDB. Okay, so we showed you the code. Now it's time for you to see it running.
Great. Who knows Kiro? The people that don't know Kiro, it's under the rocks, or? Just joking. Kiro is the new agentic IDE from AWS. It's an amazing tool to build solutions. Let's open my... Perfect. Demo. Perfect.
So the reason why David talked about Kiro is because Kiro helped us build this demo today.
100%. But spec-driven development, not vibe coding. So this is a Jupyter notebook. This is not the final demo. This is a baby step process. First, we are going to review how it works, every of these capabilities that we talked previously. This Jupyter notebook will be available in our GitHub repo, so you later will be able to interact with them.
Yeah, we have a QR code for that on the next slide.
Great. Let's start. So we are instancing a Ollama model localhost. Notice that we are using a custom model, a community model. Why? Because Qwen3, it's an amazing model, but have the thinking process and think a lot. So thinking takes a lot of time. For demo purposes, we are using a no-thinking model to speed the capabilities. And works very good. I mean, accomplish all the tasks that we have in the demo.
Full disclosure here that David's off the internet. That's why his Strands MCP server is not working.
So we are using this model, blah, blah, blah. Okay, perfect. The Ollama model is configured. First, tool decorator. We have here, obviously this is mockup data because we don't have IoT devices here. But imagine that you have some devices with some data that you can pull in production, like temperature sensors, humidity sensors, value actuators, etc. I am going to create a read sensor tool, function, but with the tool decorator, now this function is able to use by the agent.
So same as we saw on the slides, we give that documentation information to the agent so it knows what those tools are going to be doing and how to call them.
On the other hand, we have control device, basically a tool that indicates a specific IoT device that we can interact with to take another action. So I'm going to run this piece of code. We have these two different functions ready. And we have 3 devices available: temperature sensor, humidity sensor, and valve actor. How we can use this tool with an agent? So basically, we create an agent. We set the Ollama model that we previously instanced. We inject the tools, the 2 different tools that we created before, and with a system prompt, the LLM personality, we define what this agent will accomplish.
So it's an IoT control agent for an industrial facility, and it's going to help users monitor the sensors.
I can ask to the IoT agent, what is the current temperature of the production floor? So we indicate which sensor I need to analyze. And now, the agent is answering me the current temperature on the production floor. It's 2419. Let's control an actuator. The IoT agent will receive the open the cooling system, the name of the valve that needs to open, and now it's taking action. It's calling the tool to take an action and open the system valve. Another amazing capability that agents bring to us is the multi-process, multi-step operations. For instance, in a single shot operation, you send a prompt and the LLM responds. That's all. In the agentic loop, the agent receives a complex, or maybe in this case, 2 different responsibilities or operations, and the agent will accomplish every task, and after that, will answer you. So with the multi-step operation, I ask him check the humidity, first task, and tell me if it's in acceptable range, second task. Read sensor, the agent used the tool read sensor, got the storage area humidity, and then validates with a second tool if it's in acceptable range. Great, this is the first. Let's check the demo number 2, the structured output. There are a lot of SCADA systems integrated in industry, but a lot of them creates this, let's run this, create these awful responses. Basically, TXT files, without any parsing process. Basically, it's for printing and human readable, but the system needs to understand and get data from this SCADA response. So we have here different Pydantic models. Sensor reading Pydantic model, alarm info, equipment status, and production metrics. Every one of these models have a specific data definition, not only in the naming, but in the data type. I'm going to run this. So we are simulating a SCADA response. Basically, this TXT file, and then with a small agent that have a data extraction task, we can get the structured output of the SCADA report. Basically, with production metrics, we extract successfully the data, and now we can access individual fields from this structured output. We can use that structured output, as we mentioned, to send directly to other systems.
Can we go back a little bit? when we talk to the agent.
When we talk to the agent.
Here. So when we say that the structure output model is the production metrics, that's when we're telling our agent to use that pydantic model that we defined and then give its answers on that format that we are expecting.
So the third, session management.
So we talked about tools, we talked about structured output, and now how we're going to manage the session and the memory of the agent between interactions.
In this example, we are defining the session local storage directory, cleaning if it's previous. We are simulating a session ID, in this case, edge operator 001. We instance the file session manager, and then we can start interacting with the agent. You are an edge device diagnostic assistant, blah, blah, blah.
And we're giving the session manager when we're creating this instance of the agent. So we know where it should be storing session information.
We have a first interaction, a second interaction, and a third interaction, requesting the summary. We simulate a failure, and then let's recover from that error. We have a session ID, the total messages that we previously have, where are the sessions, where are the messages, and we can start talking again without any data loss. Continue the conversation. Operation continues until after restart, and it broke. Demo fails all the time.
Do you want to use Kiro to fix it?
I don't have internet.
Oh, yes.
So.
But the idea is that the session manager here, you could be using a SQL database, but here we're using local file storage. You're going to be storing those messages, and then you can restart your conversation with the agent.
The last capability is the MCP integration. Very quick, we are going to create a SQLite database, Edge Telemetry 2, because it's my second test. And we are including the MCP server SQLite directly as a tool. Here, the list of tools. I will run this.
So to the agent that we are creating with Strands, that MCP server is another tool.
Exactly. And now we are listing the tools that the MCP have, like read query, write query, create table, etc. And we can start using those tools in a new agent. We're simply passing the tools in the instance of the agent. And we're creating a database. The agent is using the create table, the describe table tool. And now we can insert Edge device data on this SQLite. With natural language, we are telling the agent to insert some data, and the agent, it's able to write the correct queries, read the queries, try to insert, and at the end, 5 telemetry records have been successfully inserted. Let's query that data that we recently write. We have an agent, the tools. We are asking the agent, show me all the telemetry records in the device telemetry table. And we use the read query tool to review every row that are in the table. Analytical query. We're asking with natural language, calculate the average value for each device ID in the device telemetry table.
So if I don't remember what's the SQL query to get the average of something, the
2
agent
years
can
ago,
help.
I wrote my last query line of code. So the MCP server was capable to read the structure of the table, create the specific query that we need to run to accomplish the task, and that's all. We have the results ready to use. This Jupyter notebook is available in our GitHub repo, but we also have in the GitHub repo our edge operator agent.
So that was the demo for learning purposes. Now we have another demo that's more interactive.
Oh, it's using my same session, so it's recovering the data from the last session.
Okay, at least here we're able to show the session management in action.
So I will ask, I open a new session ID, check this, so I can start a new conversation. So the agent answered me that the temperature sensor value is 4.26 Celsius, and the time that was recorded was actually now. So we can ask about some other states. Let's close some valve. And in the back, this agent it's calling tools, basically. But on the front end, we are interacting with a natural language. What else we have? Perfect, the humidity sensor. So we are running locally with Ollama, but let's check. Perfect, we recovered the internet. What happens if we open a new session? Or no, the same session. Only new check. We're going to start working with cloth. And now we are talking with Bedrock. So notice the latency, it's very different than the local Ollama capabilities. So let's ask again, which devices you have
So it has access to exactly the same tools. It's the same agent with a different model. Before we were running it locally on the Viz computer, and now we are running a remote agent through Bedrock in the cloud.
And basically, it's a single change of line. So instead of calling the Ollama model, we are calling the default Bedrock agent LLM. So this is the demo that we have for attendees, but we have for you this repository. Not only the Jupyter Notebook, but the full Streamlit UI and the agent running on the edge. So, what else, Anna?
I think since some of you don't know Kiro, I think it's a good opportunity to give a brief overview of Kiro.
For sure.
If you feel comfortable doing that.
100%. Kiro have to have the capability of accomplish that. So, are we in the demo?
I think one of the first things that we want to talk to you about, usually when there's less zoom, you can see a little ghost here, that's Kiro. And same as we're using, some of you might be using MCP servers with Cloud Desktop or your coding agents. We can connect different MCP servers to Kiro. And there's an MCP server for Strands. So usually we have this problem when a library is too new or when it has constant updates. If we talk to the models that have a cutoff date on their training, they're not going to give us up-to-date or accurate coding recommendations for the library. So the Strands Agents MCP server really helped us in this demo.
100%. In fact, without this Strands Agents MCP server, Kiro will be unable to accomplish the task.
Yes. So most likely when the model that Kiro's using was trained, there wasn't Strands SDK information available. So highly recommend you to use it. You can enable and disable them so the model knows better what to do and not to do. And you can just ask questions about the Strands documentations.
For sure, and not only for Strands documentation, but for AWS, AWS have more than 40 MCP servers. One of my favorite is the AWS documentation MCP. So basically, we have the 100% docs available in our LLM agentic ID. So we don't need to review the documentation because really it's up to date. It's query the real-time documentation.
And I don't know if you use steering here, but steering docs, we can create a steering doc just telling Kiro, whenever you're creating Strands code, please check the up-to-date documentation on Strands using the MCP server. So it's instructions that the agents are going to use whenever we make a request. It's directing Kiro on what to do.
I have here some steering. This was for the Road to Ring hackathon. So basically, I prepared 3 different steerings to define what we are going to do, what kind of technology, the structure of my whole project, the technology that I want to use. In this case, I opt to use Strands Agents, of course, Strands tools, agent SOPs, the MCP SDKs, and all the AWS services that I'll try to use on that project.
So similar, as we were saying that our agents in the edge need session management and memory, this is the way of giving memory to your coding assistant so it knows what your project is about, the folder structure that you're using, the technologies. So just wanted to give them that quick Kiro intro since some of them didn't know Kiro.
And really, really powerful, agent hooks, another capability. I always, for every change that Kiro creates, I am creating a commit automatically because Kiro handles all these capabilities that creates a Git commit in every task that Kiro accomplishes. So I think we can return to our session here. And as a wrap up, download the repo, check the repo. If you have ideas, if you have some challenges that you are facing, contact us. We are more than happy to help you. We are more than happy to describe these challenges for you and help to find the best way to create agents, not only in the edge, but in the cloud too. So, don't wait for your cloud to think, but use the cloud to think bigger. Thank you so much, Tim.